Am I audible to you?
Yes, sir.
Good morning, student.
Good morning, sir.
Good morning. Today our topic is EMF equation of DC machine. Just write down that heading: EMF equation of DC machine. Write down the heading: EMF equation of DC machine. So can you tell me how we produce a EMF on a conductor? Can anyone tell me?
Current into resistance.
Now, how we produce an EMF on a conductor? I have to produce a EMF or an EMF on a conductor. Do you know what is the Faraday's law of electromagnetic induction? Can anyone tell
Yes,
me?
sir. So d5 by dt.
E is equal to d phi dt. This is the mathematical expression of second law of Faraday's electromagnetic induction. What is the first law? What is the first law of Faraday's?
So Lenz law.
No, not Lenz's law. What is the first law? Actually, in Faraday's law, there are two laws. One is first law, another is second law. First law stated that whenever a conductor is placed in varying magnetic field, an electromotive force is induced on that conductor. And if the conductor is closed, then a current will flow through that conductor. This is the first law. That means if we want to create a EMF on a conductor, we have to need a varying magnetic field which cut the conductor. So an EMF will produce on that conductor. And how much EMF will conduce or how much EMF will produce? that can explain by the second law, and the expression of the induced voltage E is equal to n d phi dt. That means the induced EMF in the conductor is equal to the rate change of flux linkage. What is flux linkage? The number of turns, actually the multiplication of number of turns and flux is called flux linkage. Is it clear how we actually produce a EMF on a conductor? Is it clear to you?
Yes, sir.
Okay. Then in DC machine, actually in DC generator, tell me how we produce a DC voltage in DC generator, how we produce a DC voltage.
So by changing the by rotating that coil,
By
the
rotating the
flux
armature
armature, sir.
in a magnetic field.
Yes, sir.
Which one produce the magnetic field, or which part is producing the magnetic field? What is the name of that part? The
So
name of
the
the
field
part,
winding that.
the name of the part which will produce the flux is pole, and the coil are wrapping on that pole is called field coil. You are right. The field coil is producing the flux, and in that flux we rotate a armature, and in armature a EMF will produce. Now we have to derive the equation how much voltage or how much EMF will produce on this machine. Suppose first we consider a quantity phi. What is phi? Do you know what is phi? And
Flux
then
induced.
just write down phi. First write down phi. What is phi? Phi is useful flux per pole. That means a pole is producing a flux of quantity phi. Then we're taking another term P. What is P? P is number of poles. Then consider another term is Z. Z is total number of conductor. Total number of conductor in the armature. That means a coil consists of Do you know what is coil and how it is? Suppose what is that? Can anyone tell me what is that? This is a turn. What is called? This is called a turn. And these two are coil side or total number of conductor. What is that? These two are called actually the coil side or number of conductor. Here, what is the number of conductor here?
Two, sir.
Two. And this part is called coil end. The yellow marking part are called coil end. The voltage are produced on coil side, not in coil end. The voltage are produced in coil side, not in coil end. So which one are coil side and coil end? Coil side and coil end. This is a coil end and this is also a coil end. And this is a coil side. This is also a coil side. That means how many coil side are there? How many coil side are there? Manish?
Two coil sides, sir.
Two coil side. And how many coils in are there?
Two, sir.
Two. And where the voltage is produced or voltage induced? In which side?
Coil side, sir.
Coil side.
Voltage is
In coil side, the voltage are produced. That means this is a conductor. This black color marking is a conductor, and this black side also a conductor. That means there is two conductor. Suppose a coil is consisting of n number of turns. Suppose a coil is consist of n number of turns. Then how many coil side are there?
two in.
Two n. Good. Here we consider the total number of conductor is Z. Here we consider the total number of conductor is Z. Then tell me how many turns are there?
Z by two.
Z by 2. Good. Then we consider another term which called A, which is parallel path between two brushes. This is called parallel path between two brushes. Suppose we have a 100 number of conductor and parallel path each two. Then how many conductors are series in a path?
200, sir.
How many?
100.
No, I have 100 conductor and number of parallel path is 2. Then how many conductors are series in a path? Tell me. There are how many conductors?
100.
100. And how many parallel paths are there?
2.
2. Then how many conductors are series in a path? Tell me. This is very simple of course. Okay. Let's take another example. I have four number of conductor and if the parallel path is 2, then how many conductors are in series in a path?
2, sir.
2. Then tell me if the number of conductor is 100, then how many conductors are series in a path?
50.
50. Good. If the number of conductor is 50 and the number of parallel path is 10, if the number of conductor is 100, suppose if the number of conductor is 100 and the number of parallel path is 10, then how many conductor are series in a path?
10.
10. How you do that?
Divide, sir.
By divide. That means Z by A is number of conductor in series for each path. Can I say that? Can I say that?
So what, sir?
Z by A is equal to number of conductor in series for each path.
Yes, sir.
You have done like that 100 by 10, that means 10. You have done in this way. You are dividing
Yes.
100 by 10, so the number is 10. So the number of parallel path, sorry, number of series conductor in a parallel path is 10. That means Z by A is equal to number of conductor in series for each path. I can say that.
Yes, sir.
Then consider a quantity small n, which is speed of rotation of armature. The unit is rpm. Speed of rotation of armature in rps. What is the full form of rps? What? What is the full form of RPS? Do you ever heard RPM? Ayush, have you heard RPM? Danish,
What is it?
what is?
Disconnect again.
What is the full form of RPM? Tell me, what is the full form of RPM? Revolution per minute. And what is the full form of RPS? What is the full form of RPS? Revolution per second. Am I audible, Deepak? Deepak, am I audible? Deepak, am I audible? Deepak, am I audible? Deepak,
Yes, sir, audible.
what is the full form of RPM?
Rotation per minute, sir.
Rotation per minute. And what is the full form of RPS?
Rotation per second.
Rotation per second. That means we have write down some quantity. Phi is useful for flux per pole. P is number of pole. Z is total number of conductor in armature. A is parallel path between two brushes. Z by A is number of conductor in series for each path. And N is speed of rotation of armature. The unit is RPS. Now tell me how much voltage or EMF is produced on a conductor. Generated voltage in a conductor. How much? By Faraday's law, we know that how much voltage is produced.
And phi Z by A.
N d phi dt. Am I right? N d phi dt.
Yes, sir.
Okay, I write here E is equal to N phi. This is the expression E is equal to N d phi dt. If one conductor is considered, then what is the value of n? If one conductor is considered, then what is the value of n? Tell me, what is the value of n? Here we consider a conductor. Then what is the value of n? Ayush, Manish,
So 1.
1. Good. Then the equation becomes E is equal to d phi dt.
Yes, sir.
If the value of n is 1, then the equation becomes is equal to d phi dt. Here we considering n is equal to 1, because we write here the generated voltage in a conductor. So the expression of that voltage is d phi dt. So have you write all the things here? All the in the screen, all the things you have write on your page, on your exercise book, because
Yes, sir.
I have to erase something. Now what is our expression? Now tell me, can I write that? Can I modify the expression like that? The induced voltage expression, can I modify it like that? Ayush?
Yes, sir.
Then what is d phi by rotation? That means flux cut per revolution. I can say that. I can say that this is flux cut per revolution. Can I say that from here? The d phi by rotation. I can write it like flux cut per revolution and dt by rotation. Can I say time taken for one revolution? Time taken for one revolution. Can I say that? देखिए आपको ये समझ में आया कि नहीं? आयुष, मनीष, धनेश, खुशबू, मुस्कान, समझ में आया है? देखिए
Yes, sir.
What I write? Generated voltage in a conductor is equal to flux cut per revolution by time taken for one revolution. How we write it? From the Faraday's equation, we know that E is equal to n d phi dt. If the value of n is equal to 1, then we can write the equation E is equal to d phi dt. And we slightly modify that equation and we write E is equal to d phi by rotation or revolution, or dt by rotation or revolution. You can write that. So d phi by rotation or revolution is called flux cut per revolution, and dt by revolution is called time taken for one revolution. Now we have how much flux produced by a pole. Tell me how much flux is produced by a pole. What is the equation of that? Deepak, Deepak,
Yes, sir.
tell me what is phi. Tell me what is phi.
The flux.
Flux. Flux, useful flux per pole. And what is P? What is P? Ayush, what is P? Ayush, tell me what is P? Ayush, so Deepak, tell me what is P? Deepak,
Sir, pole.
P is pole. Then tell me how much flux cut for a or in a revolution. How much flux cut per revolution? Can you tell me? कितना फ्लक्स स्टार्ट होगा एक रोटेशन में? टोटल कितना फ्लक्स है बोलिए अभी, पहले बोलिए वो कितना फ्लक्स है वहां पर. How much flux is there? How much flux are there? Phi is created by a pole. Then how many poles are there? P. Then total value of flux is P. How much? P into phi. And what is small n? Tell me what is small n? Ayush, Ganesh,
Speed of rotation of armature in
rotation of
RPS.
armature. That means at unit is RPS. I mean revolution per second. एक सेकंड में कितना बार घुमा वो? What is the rotation in 1 second?
And
N.
sir,
Then tell me
small n.
what is the time to take to complete a rotation? That means tell me time taken for a revolution.
E by n, sir.
No, 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 no. What is small n? It is the revolution in 1 second. How much revolution is there? Small n in 1 second. Then tell me to count. Tell me the time taken for one revolution. 1 सेकंड में कितना बार घूम रहा है वो? 1 सेकंड में कितना बार घूमता है? बोलिए।
n times, sir.
n टाइम्स। देन एक बार घूमने में कितना टाइम लेगा? एक बार घूमने में कितना टाइम लेगा? n टाइम्स घूमता है 1 सेकंड में। एक बार घूमेगा कैसे? एक बार घूमने के लिए कितना टाइम लगेगा बोलिए?
1/n.
1 बाई, यू आर राइट, 1 बाई हाउ मच?
Small n.
1 बाई
N.
1 बाई n, गुड। I have to clear all that. Then time taken is 1 by n. Then we clear this. Then tell me what is the time taken for one revolution? 1 by n. And now tell me what is the equation now? P equal to P n and I. The equation is like that. Then how much voltage is generated in a conductor? Then tell me how much voltage is generated in a conductor? Manish, how much voltage is generated in a conductor? What is the expression of that?
Pn5, sir.
Pn5. How it will come? It will come from the equation E is equal to d phi dt. We simply modified that and write it like flux cut per revolution by time taken for one revolution, and the total flux present on that is p phi, and time taken for one revolution is 1 by n. After simplifying that equation, we get Pn5, and this is the voltage which is produced in a conductor. And now tell me, what is the total voltage? Now we write the total voltage. So suppose I have a battery of 2 voltage. Suppose we have suppose we have 4 battery of 2 voltage. If we connected 2 battery in series, how much voltage is produced?
8 volt.
We have 4 voltage. Sorry, we have 4 battery of 2 voltage, 2 voltage. We are seriesing it in 2. Then how much voltage is produced?
8.
No. 2 voltage as 2 batteries are series in with the voltage of 2. हमें 2 बैटरी को सीरीज में करना है. एक बैटरी का वोल्टेज है 2 वोल्टेज. 2 वोल्टेज को हमको सीरीज में करना है. कितना वोल्टेज आएगा? कितना वोल्टेज आएगा? कितना वोल्टेज? We have 2 voltage battery and the number of battery is 4. We have connected 2 battery in series. Then how much voltage is produced? Ayush?
4 volt, sir. 4 volt, sir.
Good. 4 volt. That means if we connect the batteries are in series, then it makes the final voltage. And here, how much voltage is produced on a conductor? How much voltage is produced on a conductor? Pn5.
PM
And
5.
how many conductors are series in a path? How much conductor series in a path? How much?
So Z by A.
Z by A. That means the total voltage is equal to like that. It should be like that. The total
Sir, वो
voltage is
multiplication sign है.
1 voltage generated in a conductor into number of series conductor. Then what is the final expression? Then tell me what is the final expression?
And ZP and 5 by A.
I by A. Okay, good. Pn phi z by A. This is the equation of generated voltage in a DC generator. Write down that. This is the expression or equation of generated voltage. Then we can write here E is equal to E is equal to Pn phi z by A. This is called EMF equation of generator. Is it clear to you, Deepak? दीपक,
Yes, sir.
अब समझ में आया कितना एक्सप्रेशन
हाँ
क्या
सर.
होता है? इंड्यूस्ड ईएमएफ का एक्सप्रेशन बोलिए क्या होता है? ई इजिकल टू कट हो गया मनीष
Yes, sir.
ना, दीपक आ गया. दीपक बोलिए ई इजिकल टू पी फाइव एन जेड बाई A. So now we take the attendance. Manish, are you there? Manish,
Present, sir. Present, sir.
Ayush,
Yes, sir.
Asghar,
Yes, sir.
Samsad, Samsad, Khushbu, Praveen, Danish, Deepak. Okay, the class is over. Now you may leave now.